So 2,6 is more on testing equivalence. Go ahead. Okay, so the topic of this is more on testing equivalence.
Can I go to the bathroom so I can bring that out of the way?
Yeah, anytime, you can just walk out if you need to. Okay. So you're more on testing equivalence. Okay. Yesterday we talked about testing equivalence. Can somebody tell me what does it mean to test equivalence? We did examples of this. What am I doing when we're trying to test equivalence of expressions? What's one way to test it? At the end of class, you all did an example of this. What was the way of testing it? Yes.
Seeing if the two, I can't think of it,
Expressions.
equal the same thing.
Yeah, see if you put values in for the variable and you check to see if they give you the same answer. So one way is making a table. Okay, and you put in values for x. So here you would have expression 1. Here you would have expression 2. And you should put some values in for x or the variable. It could be a different letter than x. You plug it in. If they're the same, if we do 3 or more x's, you should do at least 3. Then they're equivalent. So if they're the same answers, then they are equivalent. If you get different answers, what does that mean?
They are not equivalent.
That's right. How many do I have to say that they're not equivalent?
1.
Yeah, only 1. We have to have more to actually kind of tell us that it's equivalent, but you only need 1 different answer, and it proves that it's not equivalent. Okay? I would still recommend you doing 3 points, just so you know for sure you didn't make any math errors. So if you get one that's not equivalent and one that is, then I would double check all your math to make sure you've done it correctly. So one way is just making a table, putting in values for the variable, see if you get the same answers. Okay, that's the number 1 way we did it.
Wait, I'm not doing ready.
That's fine. I'm giving you some time. Okay, think about what is another way we could test to see if they're equivalent. What's another way? We talked about it yesterday briefly. Okay, I'll give it to you. The second way is to simplify both expressions and check to see if the simplifications are the same. Now we'll do one of these. Okay, we have 2 times x minus 3 plus 10. And I have over here, I have Okay. We want to know if these two our expressions are the same. Okay? We could do the first way, making a table. That is not wrong. That works. Okay? But we can also simplify. So here's the first expression. That means I want to simplify, do whatever I can, combine like terms, do any multiplication I can do, all of that kind of stuff. Okay? Then we want to simplify the second equation, and we're going to see if they both simplify into the same thing. Okay? What is the first thing I'm going to do here? What is the first thing I'm going to do? How do I check it? Okay, Grayson, what's the first thing I'm going to do on the first equation?
Use a distributive property.
Yeah, I'm going to use a distributive property. Now first, let's think through this. Order of operations says, do inside the parentheses. But I can't do x minus 3 inside the parentheses. So that means I have to go outside and now do multiplication, because addition comes last. So we want to do the multiplication. Because this is multiplying something in parentheses, we use the distributive property. So we're going to multiply 2 times x, and we're going to multiply 2 times negative 3. Okay? So we get 2x, 2 times negative 3 is minus 6, plus 10. So we now have done that multiplication using the distributive property. I'm not seeing people write down things here. Okay? Show yourself these examples so you know how to do it. You can go back and refer to it when you're looking at it. When you're doing the problems and you're going, I can't remember what I do. Go back and look what I did. See if that helps you. Okay. Now we are going to put together, we're not as simplified as we can be. We can put together like terms. Okay. The x is not like the other ones. Reminds me of Sesame Street. Which one's not like the other one? The 2x is not like the negative 6 or the 10. So we can put negative 6 and 10 together. When I put negative 6 and 10 together, what do I get? Ava, what do I get if I put negative 6 and 10 together? A positive 4. That is absolutely correct. Okay? So we have simplified that expression. We can't simplify it anymore because 2x is different than 4. We can't put those together. So that is simple as we can make it. Okay? Let's do the same thing over here. Now, I wrote it very similarly. It looks like a very similar one. Matthew, what am I going to do first?
Distributive property.
Okay, we're going to distribute the 2 to the x and to the 5. Okay? So if I do that, Mason, what do I get? Distribute the 2 to the x and the 2 to the 5. What do I get?
2x and then you get 10.
Yep, 2x plus 10, because it's a positive 10, so it's plus 10 minus 6. Okay? Brielle, what do I get when I do the next step? I'm going to put these two together because they're like. 4. We get 2x plus 4. Are these equivalent? Are they identical? Yes. So if they come down to the identical same thing, then they are equivalent. So if I use numbers in here, I will always get the same answers if I put numbers in here. Okay? And so that's an equivalent thing. So checking them here is you simplify expression 1 as far as you can, you simplify expression 2 as far as you can, and you check to see if they are the same. If they're not the same, then they're not equivalent. Okay? If they're not the same, then they're not equivalent. Now, if you want to check yourself, you can always plug numbers back in and be confident that you got it right in your simplification. Okay? Now, the third way that you can do it, but I'm going to tell you not to do this, it doesn't make any sense right now, is by graphing.
Oh yeah.
But if I graph, I'm just making the table first. So we can already look at the table. The graph is just an extension of the table, okay? So you really don't need to graph them because you've already made a table. So graphing, unless I give you really complicated ones, then I may ask you to go on Desmos and graph both of them on Desmos. Okay. And if you graph on Desmos, what you're looking for is, when I put both expressions in, does it give me the same picture, the same graph picture? Okay. If one's on top. Okay, so we'll talk about what is Desmos. Okay, Desmos I will show you on my computer. Okay, I'm not going to require you to do any of these, but let me just show it to you. I'm going to stop this because I don't think I need to show Desmos on here.